Okay, 2.2. More English stuff. We're going to talk about biconditional statements. The objective. If you leave today and you can recognize and use a biconditional statement, we're in good shape. Okay, first let's talk about a definition. Christian, perpendicular. Perpendicular, hopefully it's nothing new. Two lines are perpendicular if they intersect to form a right angle. Circle that. Okay, a right angle. That's 90 degrees. Devin, you got it. Do you see this little square mark right here? That means right angle. That means 90 degrees. So if line N and line M intersect, and they've got this little mark, that means that's a 90 degree angle. That means they are perpendicular to each other. This is the shorthand you need to know. Everybody circle this. That symbol from now on means perpendicular. You read it as is perpendicular to. So that little symbol takes three words. Line N is perpendicular to line M. Okay, a line can also be perpendicular to a plane. You see this plane P. So let's say the plane is trying to show a 3D object in 2 dimensions. So the plane, let's say the plane's horizontal, and you've got a line that goes through the plane and makes a 90 degree angle. So line N is perpendicular to plane P. Now, perpendicular, that's a definition, and we're going to show you how all definitions are true biconditional statements. So let's go to this next slide. You got to know what a biconditional statement is. A biconditional statement contains this. Everybody underline this. If and only if. So in your English, when you come across this, if and only if, this is going to be a biconditional statement. Biconditional statements are either true or they're false. And we are interested in looking at them and trying to prove them false. If we can't prove them false, then we're going to assume they're true. To be true, both the conditional statement and its converse must be true. That means it's true forward and backwards. If it's true forwards and backwards, then you've got a legitimate argument. Lawyers can make money with legitimate arguments. Okay, Devin, here's the phrase. 3 lines are coplanar if and only if they lie in the same plane. Tony, you got it. 3 lines are coplanar. That means they all lie in the same plane. Here's your phrase that throws you off. If and only if. When you see that phrase, what does it tell you it is? A biconditional statement. So there it is. If and only if they lie in the same plane. Okay, try and write the conditional statement. What is the conditional statement? So let's pick this apart. The conditional statement, write this. It's a if-then. Remember, that's what we did on Friday. It's a if-then. So change this to a if-then. And you're going to want to do this, I think. You're going to want to write if. What are you going to want to write after if? Yeah, let's just read it. Let's say this first part right here is your hypothesis. That's your hypothesis. So it's going to be if 3 lines are coplanar, then your conclusion is going to be this. They lie in the same plane. So your conditional statement, if we're going to pick this apart, your conditional statement is going to be if 3 lines are coplanar, then they lie in the same plane. Now, once you got your conditional statement, what is the converse? Do you remember what the converse is?
That's where you switch them.
Yes. You guys are absent. The converse is pretty easy. You just switch it. So we're going to write this. You're going to write if, and then you're going to do this part. If 3 lines lie in the same plane, then they are coplanar. So the converse, you just flip it. Okay, now, if both of these are true, then you got a true biconditional statement. Fernando, is this one true? Is the first one true? If three lines are coplanar, then they lie in the same plane. Is that true? Yes. Check. Is good. What about this bottom one? If three lines lie in the same plane, then they are coplanar. Is that true? It is. So that means this is the truth. This is a true biconditional statement. If you can argue it forwards and backwards, it's legit. Okay, this one right here. Let's skip it. Forwards and backwards. It's just talking about forwards and backwards. Okay, let's look at this biconditional statement. X equals 3 if and only if. So there's your if and only if. X squared equals 9. So question number 1. Is this a biconditional statement?
Yes.
How? How do you know? Well, what gives off a biconditional statement? This right here, the English, if and only if. So yes, it is because it has if and only if. Now this is the question. Is this a true statement? Is this a true statement? It's got to be true forwards and backwards. Andrew, let's pick it apart. What's the conditional statement here? What's the if, then? We're gonna go left to right. So it's gonna be if x equals 3. If x equals 3. So these are gonna be easy to change into if then. Just go left to right. So take if, the first part, x equals 3, then x squared equals 9. There you go. Now, is that true or is that false? If x equals 3, then x squared equals 9. False? Prove it. Why? X could equal 4. Well, let's say x has to be 3. So as long as x is 3, is this part true? Okay, so this one's true. So far so good. Now, what's the converse? Parker, what's the converse of this? How do you find the converse? You take your if. Let me do it in a different color. So it's going to be if, and you just switch it. If x squared equals 9, then x equals 3. Now, this one, is this one true? If they're both true, then we're in good shape. If x squared equals 9, then x equals 3. Is that true or false? Is that true or false? If x squared equals 9, then x equals 3. It's false. What else could x be? X could be a negative 3. Because if you take a negative 3 times itself, a negative 3 times a negative 3 is going to give you a positive 9. A 3 will give you a positive 9, but so will a negative 3. So there's more than one answer. There's more than that answer. Up.